So, what is optimization? The dictionary definition, what you get if you look on Google, is the action of making the best or most effective use of a situation or resource. But for game design specifically, you could kind of look at it as like two different definitions in the optimization of game design. There's a optimization in gameplay, and then optimization in the game design process, right? So there's the differences. Uh, why is design optimization important? As you can see with the meeting over here, I don't know if you can see my mouse. But they're the whole point of optimizing the process of game design, getting everything set up, is so that things go smoothly. Okay, cool. So the last thing you want to do is spend months and months and months on like planning and stuff like that, but you don't hammer out like certain details and you have to start all over, or you spend months and months and months like actually physically designing and then, oh no, the specifications are wrong, and then again you start over, right? So it makes the whole overall design process quicker. Better time management, so you know where at in the process you are, so you know where you can better put your time into. So like let's say you're like, okay, well it should take us this long to get this section of the game done, this long to get the art done, this long to get the everything else done with it. So you can section out time, and you have a lot of different perspectives on everything. So you can always like, okay, adjust here, adjust there, boom, right? And then always it's easier to access information and status updates when you plan and you know where they are, so you know what's faltering. Why is programming optimization important? For anyone who's had a bad computer, you will obviously know me and my $50 laptop trying to run Minecraft. It doesn't go well, right? If the yeah, exactly. Some computers are built like this. Absolutely, that is my computer. That's what I'm using right now. So optimization is pretty in programming and is pretty obvious. It allows older computers to run it. It allows for higher frame rates. You can put less wear and tear on processors. You don't wear them down as fast. For consoles, it lets you maximize settings for for graphics for their limited processors, because like roughly what their resources will be. And also, it's better readability for if you need to fix stuff as well. Honestly, some cases of like where things are not. Yeah, exactly. Renault. Fewer cycles means less power usage or heat in the system. That saves your computers and other stations for much longer. Well, much in quotes, but cases where they're not optimized are very apparent, because the whole game will run well, and then in some specific areas it'll just drop. Like your frame rate will drop, kind of like the wild area in Pokemon Sword and Shield. You walk in the whole game very pretty, doesn't lag. You go in the wild area, and there are definitely sections where like it just comes to a halt. How to optimize the design process. So, if any of you are in software engineering, you recognize this Gantt chart. This is how the process to optimizing design is kind of obvious. Just lots of planning, including planning the planning process, right? So you need to at first set aside how much time everything's going to get. As you see here, the planning portion has some here: research, design, implementation, follow-up. The start and ends, they can overlap depending on what you're doing, depending on what models you're following and how you are the process you're using to make, in this case, the game. So you do want to set up these and have timed goals, so that you know how far along you are, when you need to speed things up, when you need to slow things down, when you need to allocate more time, more resources. Also, you dividing into groups and assigning tasks and properly checking in on progress is very important. If you just say, okay, the research should be done here, I'll see you guys at that checkpoint, right? It will overall result pretty poorly because you don't, most likely, because you're not monitoring them. You're not like, oh, staying on top of them. Hey, what did you accomplish this week? Okay, well, you need to do this by next week and this by next week, etc. So having not too much, but still having enough follow up to check in on those groups is very important. Now, how to optimize programming? There are many ways to optimize programming. Everyone has their own ways of programming as well, so sometimes it's not even necessarily optimizing, but preference. But some basics is planning all the features beforehand, right? So if you know you're making a, let's say an art software, right? If you know you're gonna need a basic paintbrush, you're gonna need like a fill bucket, a selection tool, probably a magic wand because those are super helpful. You want to have all of those pre-planned so that then you can allocate how much time it's going to take for all those, and you know what to work on when, etc. Um, Over here where he says lowering the n in big O of n. I'll show you guys some examples of that later. But that basically that O of n means complexity. That's how much. That's how intensive that one process is. Commenting through your code so you can read it and others can read it is also very important. Working with other developers, getting their opinions on what's, let's say you have something go wrong, just asking someone for help, never a bad idea. Knowing your tools and how processing intense they are, that'll come important. I'll show you guys some example in a bit. And in terms of game design, what you're calling every frame, right? These are all things to keep in mind for programming, because if you do like too much of any of this, you'll start seeing frame drops. You'll start seeing possible crashes, etc. Just because you're not being efficient enough in it. So let me pull out some examples first before we have some questions. So I made a basic little scene in Unity. So in Unity, we have just 3 little balls here. We've got a ball type named player and 2 other just random objects. And then I have a script here that tells everything what to do, right? So first things first, just some basics for people who haven't messed with Unity. This line right here is just getting a reference in the game, so you can drag and drop that and be like, hey, we're talking about this object. And then this one right here is talking about a component of the object called its rigid body that handles physics. And then I'll talk about this later. Let's comment that out. So here, I'm going to comment this out. Okay, so right now what we're doing is we're trying to make these balls go forward. So here is just a basic what they're doing. These balls just run forward, right? All we're trying to do. Now, if you were to check in here, yes, very much Vroom. I just have a basic, the object reference, which is set to the ball 1. I think it's the black ball. It says, all right, we're going to get component, the rigid body, and then, which is what handles physics, and then we go inside of that and then get its velocity, and then we set its transform, we set it equal to wherever way it's facing, times the speed. So in here, this is a get component, and how I mentioned earlier that you should know how memory intensive your tools are. This function in Unity is very memory intensive. Yes, it was with malice. I'm going to force everyone here to program in C#. But in here, this is a very memory intensive process. So calling this every single frame for more than a few objects, right, can definitely start slowing your computer down. It's not something you want to do. Too many of these will just crap your reader, and you won't know what's going wrong because you think everything's fine, but this takes a lot of memory. In this instance, we have the rigid reference, which is just instead of referencing the object, we're referencing its rigid body, which means we only call that once, and we don't have to go inside of it and keep getting this every single frame. So this right here saves a lot of time in the long run. Having 50, 100, 1,000 objects, anytime someone's putting that many things in there, it's always better to have a reference that doesn't have to, know your tools and go inside and keep, like, you don't want to keep calling the memory to stuff. Find shortcut. So that's what we did in here. The object reference 1 literally just grabs this object. But down here, in objects reference 2, it's just grabbing the rigid body, so we don't have to keep going inside more and more and more in just one call. Now, if you were to go here in my code, there's something I have called do stuff start, and this is talking about the big O of n. This is telling you how many times a program's running, right? So if I have a loop that says you start at 0 and you basically run 5 times, it'll be like, okay, cool, run 5 times, right? Pretty easy. In this one, I say same thing, start at 0 and run 5 times. But then I have another one inside of it that also starts at 0 and runs 5 more times for every time that this one runs once, right? So if this runs even one time, or if you run this program once, it's running 25 different lines versus this one just running 5, right? And if you add a third one, a fourth one, etc., it just keeps multiplying over and over. It keeps making this n larger, right? So you really want to avoid, like, memory-intensive things that run multiple times per second, especially when you go to update, right? Which in this case runs every single every single frame of the game, so it runs 60 times a second. And if you check these 3 for loops, it runs basically 125 different lines every single frame, which should be in update. So if we were to just do, yes, run the update function inside the update function, so it's an infinite loop. This. Absolutely nothing. If you've ever been a user of recursion, I have never heard of anything going wrong, to be honest. Hopefully there will not be an error in here because I deleted some code earlier. Okay, so if you saw this one right here, ignore the scene down here. I told it to write down every single time something ran. So for the first one, it just says, hey, look, I ran 5 times. 0, 1, 2, 3, 4, right? Pretty easy. It just ran 5 times. That was this one, firstly. Pretty easy. This one just ran 5 times, right? And the next one, where it says I and J, runs another 25 times because it does it twice. But as you can see here, it runs it once, right? All these ones right here means how many times that one program was called, or that one function was called. And so these ran 25 times, 1 time, right? So that's not too bad. Computers are good enough where that's not much of an issue. But that's in start. Now, if you were to call something every update, which I'll get into colliders in a second, if you call something every update, that means it's going to run that many times every frame. So, save that. So if we run this again, this is running 125 lines every frame, right? So in just a few seconds, we've already called, what is that? 20,000 different 20,000 print statements, which not that bad. But if you call 20,000 movement statements or 20,000 spawning, like instantiating, like making objects, if you do anything 20,000 times, it's obviously going to be an issue. And that's where colliders are fun, which in games is how they check if things are touching. They'll be like, "Oh yeah, look, I've got a collider. We're right here." And if you have too many colliders, it's just going to run that a million times per second. And then if you run other things like that, like multiple for loops inside of the collider, it's going to take a lot of memory, which is something you want to avoid in games. So the best thing you want to do in programming is trying to whittle these down as much as possible. If you can whittle it down to this, great. If you can whittle it down even less, that's even better. And yeah, so one thing that's useful in camera occlusion, which that could be its own thing because it's pretty useful, but camera occlusion, you can you can just stop rendering other things, so that saves time. Stop limiting how many objects text their collisions with one another is also very useful, just because any collider that's not a square is really, really hard. Or like it's hard on the computer not turning off by having too many. So yeah, things such as like preventing how many collisions happen, or like, preventing their programs from running, or at least disabling them temporarily. Anything that you don't need to be testing right then, try not to have it testing for collision every single frame. That's about all I have for optimization. Could go to showcase if anyone has that.